Good day.
Buenos días.
Buenos dias. I do that sometimes as well. I only know a handful of Spanish words. One of my favorites was just a phrase that my friends and I made up. It's El Blanco Vaca Diablo, so the white cow devil. No idea why we came up with that. It was just one of those random. We played a lot of Diablo 2, so that's probably where it came from with the secret cow level and stuff.
Oh yeah.
But yeah, my Spanish is limited. But I'd say Donata. And
Do you speak any other languages?
no, I don't.
No, you don't.
Okay. I wish I did, but I don't.
Yeah, I actually grew up speaking Spanish at home.
Oh, awesome.
Yeah. My family's from Peru. So
excellent.
Yeah.
Well, then that makes a lot of sense.
Language, but like, yeah. Anyway, yes. Hi. How are things? How's everything?
Pretty good. Going to be a busy week.
Busy week.
He speaks Go. Yeah, that's what I do. So if we count programming languages, Tech Davis is right. I do speak Go. Moderately confidently now, which is fantastic. Yeah, the weekend was good. It's going to be a busy week, but it'll be better next week. How about you? So you hadn't talked to a human in a little while?
Yeah, it's been a minute. My partner's traveling, which means it's just been me and the cats and the plants and learning new keyboard layouts. So I've kind of lost it. And hello, this is my first human interaction in like a minute. So
yeah, we went down a deep. We should probably have recorded that. We should do some segments on keyboards, I think, in the near future.
Yes.
So you're going like you're pretty convinced that you're going to go 30%. Probably.
Yeah.
Let's drop a link. I'll put that in the chat for everybody so that they can see it.
Yes.
And be impressed.
I mean, the be impressed part should be afterwards once I've like actually done it, because hopes and aspirations ahead of time.
Yeah.
But
all right. Well, today I think we're going to be diving back into the component work, so we can get that going, and we can learn some more Rust.
Let's do that. So I don't fully remember where we left off, but I did manage to pull up all of the repos again, so we can dive in, see what we were doing, where we're left. Is that legible? I think so, right?
Yeah, perfectly legible.
Okay, great. Let's say this, and then what happens if we do a cargo, or I guess a /run? What is the output here? I don't remember. What are we even like running? What are we building?
It's been a minute. I think last we're working on the client, right? And then we ran into some issues with the content length, but then we decided, hey, we're just going to let the server side just figure that out, and it was able to. And so what we were doing was trying to get the request, the client, basically. So we're trying to create an interface that we can swap out models underneath. So we're building the client side, and what we're working on is getting the client to send the request to the server. I believe is where. That's what I remember leaving off at.
Yeah. And then I think after stream, maybe I was like, oh, I'm going to do some more tinkering and figuring out. Oh, yeah. We were like with okay. The HTTP stuff and the streaming. And then I was like very grumpy about it because I was like, I don't even know if this is spec compliant.
Yes.
And then I sat down afterwards figuring out some stuff. Okay. I have an answer to the question. Is this spec compliant or not? The answer is yes. Yes, it actually is spec compliant.
Okay.
Doesn't mean it's a good experience. Doesn't mean people should be doing what this thing is doing. But apparently in HTTP, you can just send data as your body and then terminate the connection afterwards. And that is fine. Like a client or a server should be happy to just accept that. It's like there's like 8 different cases, and this is like the 8th like HTTP 1.1 fallback case. Where they're like, well, all else remaining, just read bytes until the client terminates connection. And so that's what this was doing, and it was like, okay, there's bytes remaining, there's like weird stuff happening. But then I found out that Olama, you can ask it to like set it in non-streaming mode. You can make a request as like just, with a known length, it'll just give you that, and then you like don't need to like interpret a bunch of messages. It's just like the one response. And I got that to work, and then I start generating some schemas, and now we have a schema for a response that should work in most cases. I think I've gotten it to work so far. But so that is this right here. I had a little file called schema.rs. It's 40 lines for like the request and the response. And I, just dragged and dropped the JSON and was like, please generate me a schema. It's like that schema generation website. I forget what the URL is. But yeah, this works. And there is now a field pub stream bool where you can ask it to like, please do not stream into a request. And I'll give you like a concrete output back.
Okay.
And so that's what we're doing now here. And then we just read the content length. And then we say, hey, please read bytes until the end of it.
Cleaner.
Yep, definitely. And here we, so line 49 is like read to end, but we read the bytes until it's like the end of it. And then line 50, we parse the string, the response, which should be JSON. From JSON, we parse it into like data structures. Okay. And then we get line 50 out, and then we print that right here. That seems to be working. So let's ask it a little question rather than 1.1. It's a good little question to ask here.
Ask it for like a 40% keyboard or something, like a model. Or is that too specific? Or what color is the sky? Maybe that's even more simple.
What colors? I like your question about keyboards.
Okay, let's try it.
What is a 30%? 40%. Let's not assume it like has.
We might be too niche with the 30%.
Yeah. What is a 40% keyboard? And then we run it and see what it says. So one thing that's happening here is we're no longer getting a streaming response. So we no longer get the tokens as they're being generated. But that, so panic. But that should be fine, I think. Oh, max 1024. Oh, fun. Okay, something in their parsing went bad. But that should be fine because the infer interface in WASI that we're trying to target, it's not streaming either. It just says like, here's an answer. Okay, so we have a little error here, something with a logic, where we are slice index starts at 1024 but ends at 843. And that should be max equals self.buff offset plus max. Let's try this again. Where this thing should have a length of n bytes, but then the max index should be like something like that. So we were not adding it to the lower bound, I think.
Okay. Still different length, right?
Yep. Range and index 1855, out of range for slice of length 1024. Okay. So our reading logic here is broken. This is the very mundane part of like doing anything with this. Okay, so this little piece of code here, the impl async read for incoming body, what we're trying to do here is just read bytes and make sure that we read all of them until we are like done reading, basically.
Okay.
And what we're trying to do is like read in chunks. So we say like, hey, try and read 2048 bytes max every chunk. And then we try and copy the bytes out here. And then we keep going until we like have some bytes that we've like read. Self buff, insert buff. Okay. So we now need to debug this logic somehow without having unit tests for it, which is very annoying. But hopefully we can like make that work. Yeah. Okay. So okay, let's try and figure. I'm very conscious because I'm like, okay, this is the type of code you like need to sit down and like read and debug and figure out, and it's like a little bit of a slow loop. So it's
That's
not the
fine.
most interesting, but maybe it'll make for a good exercise.
Yeah, it'll be good in the end.
Yeah. Okay. So we have a out param here, which is our out buff, a result of use size, where use size is the number of bytes we've read. Then what we're doing is actually let me let me just use my keyboard. What we're saying here is we're gonna loop until we've read some data. And we say let buff equals match self.buff. Loop let buff. Yeah, okay. So the loop folds here. So the loop is essentially the entire body. We're happy to like keep reading in the body until we've read a number of bytes. Or should we? Break, okay. No, we're always breaking at the end of the loop. There's no point in the loop here. Okay, that loop was useless. We can keep going on. So our error is happening. Where is the error happening now? Line 148. Is it? Oh, no.
We have to rerun it to figure it out now, but
yeah. But it's happening in this block. It's
okay.
not happening here.
Above.
Yeah.
So in the copy, because the copy's index is larger than what it's trying to copy into. Is that what it is?
There's something with the offsets that's like wrong, but means we can minimize this most likely. Because what we're saying here, the logic that we're saying here is if you don't have a buffer, if you have a buffer, return a buffer. So internally we're like, okay, we're like reading bytes into a buffer.
Gotcha.
If we do not have a buffer, then read bytes into that buffer. And the maximum number of bytes that we'll read is this number of bytes. So 22048. It's the max number of bytes. But then we don't know how long we don't know how many bytes we've like read. I think. No, we do, because that's a fixed size buffer. That's a vec. Okay, so we do know the thing. Okay, great. Okay, so this code is going to be correct. Has to be.
Okay.
And we're running into issues here where we're calculating the size, our offsets. Because what we want to do is we want to know, so the read call, okay, what's happening here is the read call will call multiple times, and it may not process the entire buffer in a single go. So we have a file system like read operation, which is our line 117, and that gives us like data. And then, okay, cool, now we have data. And now we may get multiple calls to this function on that same piece of data. So we need to keep track how much data we've already sent so we can finish the buffer and then be like, okay, we're out of buffer. Like reread, here's the new buffer.
Okay.
And so we're trying to, the self.buff offset is how many bytes have we already read from the buffer? Then the buffer itself is an option, a vec. Once we finish reading the buffer, we discard it, we do a new read call. And then what we're trying to make sure is that we like between calls, we update our logic. And right now, we're saying max is 1024 for some reason. I don't know why. So that would be 148 max. Okay. That's a suspiciously round number. But that may just be because like in our main, we're like doing something here. 1024. Yeah, here. It's coming from here. So here we're reading data, and that should not affect this. This should always work. It should never panic here. So something's wrong. Okay. Then we say what we're trying to target is the here. What we're trying to say is like, however many bytes we may have internally, self.buff.len, or I guess buff.len. Self.buff offset. These are the values we're like interested in ahead of time, which is like how much is our, and then I guess buff.len. And we can remove this. Now we have independent. Okay, let's try this. So the 3 lines I've added, 135 to 137, that's our like variables. Something's wrong with those, or something's wrong with our logic. So let's see what the output is of these as we're like running through this. Because if like, you know, we're like just running, I don't know. That's sort of the first click stop here.
Okay.
Main panicked at 78. What? Unwrap on a none. That's new. What?
Where's content?
There's no content length? What? Why is there no content length? What happened?
maybe go back to the original question 1 + 1. Like maybe the request is just the response is completely different.
Maybe. Did I change anything?
The only thing we really changed was the content, like that question.
No, but like the last run was like fine.
Mm-hmm. Oh, that's true with the same question.
Yeah, exactly. So it's like it changed underneath us somehow.
Okay, that worked.
Yeah, but now it's not hitting the error either. Right?
Maybe because the other one gives that's going to be a really short response. So maybe we should try something like what color is the sky, or like a little bit longer, because maybe it's trying to return like a lot of stuff. I don't know.
Yeah. That's why like the question seemed fine. Like, what is a 40% keyword? But then like for the HTTP headers to like change, I'm like, what? Now we're hitting 7810. Unwrap on the nut. Okay, hold on. So what are we getting here? Maybe it's like capitalizing it or something. We are getting content length. Yeah, what?
0.
Yeah, check it out. Our headers say there's content length.
Yeah.
Yes. Oh. And it works. What?
Now, we didn't change anything, did we?
Nope. But now we're panicking on line 143.
Okay.
Not 78.
Interesting.
Do you see a weirdness there?
It's a little inconsistent.
Yeah. I mean, like, AIs are like fuzzy machines. They're not precise logic. They're like statistical, like likely answers and stuff.
Mm-hmm.
And I respect that. I'm fine with that. So like a degree of inconsistency is fine. But for the shape of the response, like radically changing this, I'm like, what?
Yeah, I wonder how much we're going to run into that with the response being changed.
It
We'll
must
find
be
out.
that
Sounds like some good tests.
or bug fixes to upstream. Like I would not be surprised also.
So now it's saying it's trying to copy from the buffer into a slice.
Range end index 197 out of range for slice of like 1024.
So it's too big for the slice.
So our bufflen 135 here is 1971.
Yeah.
And we are trying to read range index out of range for slice of index 1024. So we're trying to read the end index somehow out of this. So we are, what do we got? Buff.len is we are trying to read that out of, 143, 0 max, copy from slice. Oh, fuck. Okay, we're calculating max wrong, clearly.
Max. So what is max in this case? Like 140. What should that be?
Okay, so we've got two buffers. Yes, the out buffer, the buffer we're writing into, and the buffer we are reading from.
And that's the response back from the model, like that we want to read from it.
The buffer we're reading from is from the model. The buffer we're writing to is the out,
Our
the
client's
user
out.
provided. Yeah.
Okay.
What we're trying to make sure is that we never do an out of bounds write on either, or an out of bounds read for that matter. So we can never read more bytes than the buffer is long. So we can never read out of its index. And similarly, we can never write out of the bounds of where we're like going to write. So what you need to do is you need to find the intersection between the two.
Okay.
And be like, take the smallest size possible and use that. And then we do that. And then we won't read the entire buffer, but at least we'll never do an out of bounds write. And then we tell people like, well, we read n bytes. And then, the client knows like, okay, I've got to call this in a loop somehow. And I'll like call it again. And we'll just write the remainder in the next call.
Okay.
Does that track?
Yeah.
Yeah. So I'm 140 is load bearing here, where we're like taking the number of bytes left to read from the buffer. And we say, take the minimum of like between the number of bytes remaining and the length of the buffer provided. Take the lowest number. So here, that should be buff.len and then 971 versus 1024. Like the number should be 971 flat. Oh, okay. I know what's up here. That should be len. That should be len. That should be max. That should be len. That should be len. Okay. Let's try this. We needed two variables. One is the number, the number of bytes we're going to read. The other one is the maximum offset here for the slice itself.
Okay.
And then we increase by the number of bytes we've read. And we take like the number, like that should be there. Okay. I think this should, if we don't hit the other error, then this probably gets us further, if not fixes it like outright. Okay. Is it 73 again? Range end 2001 out of range for size of length 1024.
So how did it get to 2001 now from 1974? What was that? It was?
Yeah. I mean, the answers will be variable length.
Okay. And that max is the actual answer. Okay.
Yeah. So buff.len 2001. So that's the actual buffer length. And for some reason, we are hitting buff offset. Okay. What is the math here? Okay. Bufflen 2001, buff offset 0, out bufflen 1024. We then buff offset 1024, that checks. Out.buff len 1024, that checks also. And then the answer should be 2001 minus 1024, so 900 and something, but we're not getting that. Buff offset, buff len.
Len should equal that number.
Max should equal that.
Okay.
Yeah, len should equal that number, and then max should equal that number plus that. Range and index out of range for 201. 67. Oh, we're getting an error here. Which is because we're returning max here and not len. Okay. Okay, that makes sense. So our logic here was correct. We just, apart from like this, which was tripping up the other side here. Because it's saying, hey, I read like 2,000 bytes, where it only like read. It shouldn't have like ever been able to read more than 1,024. There we go. Okay,
hey, there we go.
Okay, what does computer chat believe about mechanical keyboards? A 40% keyboard refers to a type of compact mechanical keyboard design. Yada yada yada. Often with some sacrifice of functionality, no numpad or function keys, accurate. Tighter key spacing, not necessarily. Oh, in that sense. Okay, not wrong. Benefits.
Ask it about the canary layout.
Oh, that's going to be niche. Let's see if it's been trained on GitHub. Or, I don't know. I feel like it's so niche. Like, this might be fun. What's your take? What is the canary keyboard layout? Meanwhile, we can delete some debug segments here. Oh, actually, we can just delete these. Okay. Oh my God. A very specific question. Okay, yeah, we're starting off strong. Is it created by this person? I don't know.
Fact check.
That seems fine. Here's a rough outline. No, this is QWERTY. What? Yeah, check it out. It says like, here's a rough outline of what Canary is, and it just gives you QWERTY.
Oh, okay. So it makes it doesn't really know. Thinks it knows. It's hallucinating. So if you want, go ahead.
A little bit. Like most of it is like kind of accurate, but then.
Well, I think it's kind of the danger with a lot of the responses. It's like they're mostly accurate, but then with a hint of inaccuracy that if you didn't know already. So
definitely. Apart from this sentence, like it seems accurate. Fine.
Would you mind taking a step back and help me like walk through the project just to build a better mental model?
Yes.
So we're getting responses in the terminal now. Like, how does that set us up for the next stage? Because essentially what we're doing is building a client then. And the server side is the web is already handled by.
So the server side is Olama.
Oh, okay.
Right. Okay.
Okay. Go ahead. Take it away. Take it from the top.
Yeah.
Refresh my mental model here.
Okay. So here in our workspace, we have two projects. WSTD and what I've dubbed Playground WSTD. WSID is a standard, like a Rust standard library-like project, but it also includes support for HTTP. Is a thin wrapper around the Rust bindings, around like the WASI system calls, basically.
Okay.
So it's like, okay, we're going to take these, we're going to create a minimal wrapper around it, so we can have something that is usable and somewhat nice, but only works on WASI, and that's fine for now. That's fine for now. Then in our playground, what we're doing is we're taking that and we are creating a client out of it. So like an Olama client. Initially, we also have example client here, which makes a request to example.com. That was like our first bench where it's like, hey, can we do a get request to example.com? And yeah, that worked. And then Olama's a little bit more complicated because we're sending JSON data and expecting a response back, So that is.
Can you go into the WSID again? Like, what are we using the WASI for? Is it I know, is it the standard?
So we have all of these submodules here: HTTP, IO, iter, net, rand, runtime, time, and inside of it, we're doing things. Like, for example, here is an API to create an asynchronous interval timer. So it waits for whatever duration you give it, and then it ticks over. That's an asynchronous stream. Here in Rand, you want random data? Yeah, cool. Here's an API for that. And under the hood, it uses the syscall here, which is coming from the WASI crate, which is coming from WASI. And then we create these little thin wrappers around it.
And what is all this what is all this bias, in our application, which would be the playground application?
It means that we can write things like here, right? We say request new with a method get with this URL, and it just works. We say send.await. That looks really nice. It's very high level, sort of like Rust feel. Here internally, what we're doing is all sorts of black magic.
But that's all handing it to the WASI. What would be the proper term there?
It's kind of you can kind of think of it as a virtual operating system.
Okay. So instead of binding myself to libc and Go or anything like that, that's the benefit here is I'm using WASI. So then I have different, then I don't have to care about the deployment target and all that good stuff for it compiled to. Mm-hmm. It'll be able to compile into a WASM file.
Yeah.
And deployed.
Earlier today, before stream, you were telling me about how some of the things you're working on, developing on Windows would be kind of hard. You have to use Linux probably because it's not been set up for that. And indeed with this, say your work was based on WASI, it would just work on any OS because as long as the runtime provides those mappings, you're set, you're good.
Interesting. I've got to find some kind of project, a simpler one, for myself, just so I can feel the benefits of it. Because that does seem ideal, because I've been going through it down. I've been rebuilding my dev environment every 3 months, it seems. And I constantly switch back and forth. Some of it's just for fun and playing, but it does get I want to be able to have a nice, clean environment that I can just kind of click a button and it's ready to go. And that's probably my infrastructure as code background where I'm just just make it so. Just make it so.
What if I had to do a project, and I don't have the bandwidth for this right now, but I have a Synology NAS sitting in my server rack in the hallway that I use for my media and stuff. But it's super underpowered, and getting anything to run on there is such a pain. It's so underpowered I can't even run Docker. What I would love, if you're ever looking for a project, it's building a server operating system that uses WASM time or something like it, and then says hey, we're going to build essentially what is a Docker-like environment where you can just pull in things, they'll run them for you, but accessible through a GUI of sorts, meant for small use. Maybe that is actually what Spin already is, and SpinCube is the Kubernetes integration. Maybe we should just be using that and being hey, can we get it to compile to something? But along those lines, I think would be sorry, I'm giving you like my pet project here. Where like maybe what you're saying is like, hey, I should find an application, not like build an operating system. Yeah. Okay. Sorry. Okay. Never mind.
Game. I'd like to get there at some point. We'll see.
Yeah.
I don't know. I'm trying to think through. Yeah, because if the project is all based on WASI, I don't like. There's no operating system dependencies that can be built into the project, so my build environment doesn't need to be so like, I don't know, doesn't need anything essentially. Like it needs to have a WASM runtime.
Yeah, I mean, unless you're building from scratch, right?
Yeah.
Like if you like we were doing the other day.
Oh wait, I need like Rust cargo component.
Yeah. And there was like
but that's pretty minimal, you know, not like this library here, this package here, that package, this package, this particular configuration setting, like all that stuff is what I'm talking about. Where it's like, I could probably make it work on Windows, but it's just not. It's not worth it.
Yeah,
for
definitely.
Now, at least with the projects that I've been working on. So.
Yeah, for sure.
Cool. Okay. That's making more sense now. So the playground is really just using that, exercising. It's supplementing for unit tests right now is what it's doing.
Basically, WSTID is like the easiest, simplest like thing I could like throw out there to be like, hey, everyone, you can start playing around with like HTTP and WASI today. Is it good? I don't know. Is it fine? Probably. Like, you know,
as so what would be missing if I just wanted to pull in like WASI HTTP? Like say I was doing just this OLAMA thing and I didn't need random and I didn't need other things. Right. I think you put them all together to kind of like wrap them all in one particular component, if that would be the right word. But like, what if I just want to use HTTP? Like, WASI HTTP? Like that would be the web clippy example, right?
I mean, I did release a project called WASI HTTP client that I based this on. And theoretically, you could pull that down and get a very broken version of it, like locally. But, you know, this entire project is 1,300 lines of Rust, like 1,000 lines of Rust with like a dependency that's like got 0 generics in it, like almost nothing. Compilation time for this, including HTTP, should be next to instant. Like in terms of dependencies, we've got like pretty much nothing in here. It's the WASI crate, which is like standalone, the URL crate, which has a little bit, but not too much, and the slab crate, which also has a little bit, but not, it's a data structure. And like that's what we're like doing. So, you know, I wouldn't worry about like, hey, I'm pulling in too much. It's like, nah, that's pretty quick.
Oh, I'm not worried about that. I was just curious, like, what is missing in those other, like WASI HTTP that like what I need to add to it to be able to use it, you know?
I mean, I can walk you through it, but the answer is a lot. Like I wouldn't have built this if this was like easy, right?
Mm-hmm.
If the underlying layer was trivial to use, then yeah.
Okay, so the underlying layer, so it's a lower level enough where you have to create like all the async wrapper around the body to be able to send it the body. So all these higher layer constructions, like if I were to import would a fair analogy be like a framework? So like the standard library in Go has some HTTP stuff, but there's like Gorilla and some other web frameworks in Go that make it easier. So I can do that higher level, like client dot whatever.
I wouldn't call this a framework, no. The way I think about a framework is it is when you pass it, like rather than you calling the code, you give it code for that will call it. So it's like a plugin system almost.
Gotcha.
Right?
Okay.
Like that's kind of what frameworks are.
A little bit lower level than framework.
This is very much a library, but it wraps like the lowest level system calls into a nicer to use one.
Oh, okay. It's clicking now. So yeah, they're just giving you the system calls to be able to do those operations, but they're not really constructing anything for you. And that's what you're providing here is that structure of, you know, like a client typically has these different methods. You know, like here's how we should handle the body.
Yep.
Okay. That's all not included in that standard library,
Exactly.
like WASI HTTP. Okay, so that makes more sense. When I looked at it, I was like, I don't know what to do with this.
So here we construct this thing. We take a handle to a reactor. Like reactor is not a WASI concept. It is a concept that we're like using in Rust and that, or C or whatever, where we wrap a specific syscall, allow it to be managed, and the WASI API wants to be used this way. That's what it was designed for, but it doesn't give you that functionality out of the box. So we like have to wrap it, and then we have a notion of IO copy. That's a system call, and like it copies bytes from one place to the other asynchronously. There's like multiple layers going on. It's actually kind of difficult to like do this, where you need someone who's very comfortable doing this, like me. Yeah, I'm not gonna lie. I've written stuff like this so many times that like I'm pretty comfortable. But then once you have this, like then the higher level layers become easier.
So you wrapped all those standard, all those lower level. So the WASI HTTP WASI. There's one for like the CLI. Is it like STID? Or
in WASI, the name for CLI?
Yeah. What's the WASI pack? Or are those components like WASI HTTP? They're called components. Okay.
Yeah.
Okay. Or so you're just like wrapping them all up.
Proposals is what we say. There's WASI CLI as well.
A CLI. That's what I was looking for. Okay. Those are called components.
It's a good question what the right names are. Specifically, they are proposals. And then you have things that we call worlds.
Okay.
And then what are the top level things? There's a name for what this specific thing is, the HTTP there. I forget what it is.
I should start writing all these down so that way I can like document the terminology.
I have a blog post for that actually.
Oh, please share. I will read it.
On my blog, WASI. What is WASI? What is WASI? It's called. Hold on. I'm gonna send you this. Because I about a year ago, I too was like, I have no idea what these words mean.
Okay, put that in the chat for everybody.
And then at the bottom is like appendix. It says like, here's what the words mean.
Nice. There we go.
In the WIT format. Hold on. Is that a namespace? No, it's called a package. Yeah. Okay. Package. That is a package.
All right.
Okay, so terminology time. WASI HTTP proxy. Then this is the how are we gonna do this? This is the namespace. This is the package. And then finally,
impressive ASCII skills, by the way.
World. Thank you. Does that make sense?
Yes. Namespace world. Okay. So WASI is the entire, and that's what you meant in the release. Like it's a reserved namespace.
Yeah.
I believe I read that.
Correct.
Okay.
So all the WASI proposals, they start with WASI, but then the Bytecode Alliance can like create their own and start it with, for example, BA and be like,
so are you making cities then? Have you made a city with WSTID? Because there was a world and you made sense of the world. So
yeah, that's right.
Yeah. City. Okay. Villages? I don't know.
Next up be continent though.
Yeah, you're probably right. Continent.
Yeah. Yeah, there's continents, and then the inverse of that is ocean.
Okay.
I don't know.
And then you just get lost in the ocean. There's like no usefulness of it. It's just void.
That's right. That's right.
Okay. Okay, that's making more sense. That's making a lot more sense. I think next time I'll have to drive and just like painfully go through it. You're much more efficient at it, but I learn a lot having you walk me through it. So I can definitely drive next time as we go through it.
Yeah, for sure. So we built a standard library. By the way, in WASI 03, hopefully like a lot of this stuff will be less, because right now we're doing a lot of manual binding, especially around async, because WASI does not have a built-in notion of async. You can build async APIs, but it doesn't like say, here is our async function. That's coming to WASI 03, and that will make all of this stuff a lot easier. And then so that's hopefully like we'll need less of this, fewer things, maybe even like no bindings, although I don't know. I was going somewhere with this. I forgot. I lost my train of thought.
That's okay. Well, we're in a good place now. So like the playground, we can interact with the Olama. Like what's our next step? I'm not saying we need to dive into it, and we're getting close to time. But what's our next step?
Good. So right now, what we have is, sorry, I'm scrolling a little bit. We can indeed make this request, and that is working. I'd say the next step is let's factor this into a component, because what we want is we'd like to use the infer API that the Spin SDK uses.
Okay.
So we use their API as a starting point. We say, okay, we're going to take our stuff, we're going to wrap it in that so it looks like that. And then we have created our first component that will hopefully actually work the way we want it to. And once we have that component, we can like adapt the playground. And the playground, rather than saying something like, here, I can like pseudocode it, I guess. Something like this. And then we say, rather than, this request or, and then, so this is what we're doing today, right? Something like this. We would be able to say LLM infer, and then name of model, and then query. Something like this. We reduce it down to just that.
Nice. Okay.
Because that's essentially what this is, right?
Mm-hmm. Yeah, all of our input could be kind of abstracted with those two things.
Yep, exactly. And then hopefully that's enough. I should also like inline this into like the HTTP request. Oh.
So how is infer working? Like, how does that allow us to abstract, like encapsulate all this stuff?
How does infer work? Well, abstractions are just, layers upon layers of like things. We could like start by creating abstraction here first, or say something like, let's define a function infer. And then it takes two params. And what we'd basically be doing is changing this from doing it in Rust to changing this from happening in at a component layer. So right now, this is like a Rust level abstraction, but with components, you can like stick it inside of a separate program and like link that in, and then it becomes like there. But it's like model string, something like that. Or I guess it's Spin has something like model, and then here we say llama 3.18b, llama 3.318b. No, shit. Nope, hold on, my mouse is like hovering over things it shouldn't. Non-exhaustive, because we'll add more. match model. And then what we'd say here is like, here, make a request. Does this make sense, what I'm doing here?
Let me examine. Let's see here. Not too much. You mind walking me through? Like, so we got our Olama.
Yeah, for sure. So what I'm trying to do is I'm trying to like define something like this.
Okay.
But at the Rust level. So defining a new function infer that we can just call and we'll just do the right thing. And basically what it will come down to is doing something like what we're doing here. And if we abstracted this API, we could say something like, okay, what do we take here is we take a name of model, and then we take a query, and then that is all we need.
Okay.
So we take a model there, and then we take a query here. And then now that should always work. I can delete this.
Okay, and so that's where that whole like worlds export, like they have, does that play in here?
We're not doing anything with world exports right now.
Okay.
So I'm creating a higher level infer thingy here. Hold on. I'll finish showing this in a sec. So the model we're using was, actually, what was the model we were using? The string for that?
Was it 310B or something like that, or 311B?
Yeah. Okay. Yes. So here, llama 3.1 colon 8b. And the second one is why is chat so nice? Sorry, I'm pandering here. And then that should work. And then what we say here is this will return a, not a result of that, but a result of string. Response there, and then we say response dot whatever the output here is. Request response done message dot content. Question mark can only be used resulter function. That should be fine. Infer. We can forward this again. Where we say model query like that. React model query, that should work, but it's unhappy for some reason. Found reference client. Okay. Oh, and this needs to return a result. Mm. Almost done. Now we need a trailing OK. And that might be it, I think. There. Okay. So now what we have here is our high-level async infer API that says, hey, I am going to take a reactor, the name of the model, and a query, and it will execute whatever it is. And then we've implemented it here, and it calls the abstract like Olama request function. But at the top level now we have this abstraction. Now we can call this. We could even like make it a little CLI where we like get the first argument from the command line or something like that. It requires arc parsing, and I'm not gonna right now. Now it's like it's spinning, it's doing stuff. Content type, application JSON, no header. Oh, check it out. We have no content length header.
Again?
Yep. Because it decided to stream, I think. Probably.
Was that just an option that you specified to not stream when you make the request through the Olama API?
Yeah. Stream false, 57 right there.
Okay. But it no listen? But it's not listening to that route?
I don't think it is. It might be that like it takes a branch or something that doesn't check the variable.
Okay, we got 2 that time.
Yep. So we get the actual output. Now if we remove this, then it'll like render a little nicer. 1 + 1, yay, 2. And now it knows it. But yeah, now we have our high level infer API.
Okay.
Now for next time, the exercise will be to move all of this code basically into like a separate component. So we can then like do, so I haven't shown this here, but create bindings to a wit schema. So we can say new folder, wit, and then world.wit or something. And here we can stick the LLM interface. Okay. And then on the other side, we create a new thing and we move the logic in there. Now we have our self-contained component that we like link in here, create bindings to, and then supposedly also call.
Very good.
But then, yeah, it'll look something like this. This will remain the API for that.
So that's that's what it'll look like in our code next time. Like it'll just be that as simple as that. Okay.
Yeah, exactly. Okay. And then once we have the component, what we can do is like, okay, great. We have one component specifically for Olama. Now let's make one for OpenAI.
Okay.
Okay.
Sounds good.
Okay.
Making a little bit more sense.
Okay.
It'll be more clear over time, but it's making more sense.
Yeah. Okay, I'm glad. Sorry, I feel like a little bit of like what we're doing is like I come into these streams with like a lot of assumptions where it's like, oh yeah, of course everyone knows what dynamic linking is. Like, oh sillies, who would not know that? It's like most people do not know that. Yeah, exactly. So I'm like, okay, how do I explain dynamic linking? How do I explain like typed interfaces? You're like, oh, okay, I see the abstractions here.
Well, it's always a good lesson in programming for me, so I appreciate it.
It's a great lesson in like explaining for me because I get to like work through like unbuilding my assumptions and be like, okay, hold on. If you don't know this stuff, what's the easiest explainer to get there? It's like, yeah.
And if anyone wants a good explainer, let me pull that up from our conversation with the WASI and programming language analogy that you had. That was super helpful for me. I'm going to pull that up, put it in chat. Let's see here. There it is. Yeah. Let's see here. Share. Start here. Yeah. We'll put that there.
Yeah, I appreciate you you making that video. It was super fun.
I'll have to do more of those.
Yeah, that'd be cool. I can you imagine like on the Azure channel, just like nonstop videos about keyboards, just like geeking out. It's like
We totally
like,
should. I think
it does this have to.
Yeah. Like, who are these two people that continually talk about keyboards?
Yeah.
Like, they're even asking their models about.
Yeah.
We're a little
just
obsessed.
a big ruse.
Yeah, it's a big ruse, and then like we're secretly a big sponsor of 40 minus keyboards. That should be a company that we should just start a keyboard company. 40 minus keyboards.
40
so
minus
like
keyboards.
you can't like form factor stops at 40. Like you can't. We don't sell any more keys than 40.
I'm fully expecting you to like try out a 30%, and then you're like, oh shoot, like we're not going back after this one.
I think I'll get there. I think I should. What I typically do. I think I got this from maybe it's Atomic Habits by James Clear, but it's the grand gesture, like to start new habits. And so you, it might be from one of Cal Newport's books. I can't remember. But essentially, like you make an investment to pull yourself into whatever it is. So instead of like doing all the research and maybe getting my HHKB set up with Home Row, like just buy the 30% and then have it sit there and stare at me until I actually, do something with it. I do that with books a lot.
Okay.
Like I have the intent to learn whatever it is. So I'll buy it and I'll set it on my desk and it'll sit there until it finally convinces me to pick it up.
Yeah. That's fun.
Although the 31 that you shared, it's quite a bit cheaper than the Moonlander. The Moonlander is like $100.
Yeah, I was looking at it. I was like, hey, this thing is like surprisingly affordable.
Yeah.
Because like, yeah. So, oh my God. Have you seen ceramic keycaps?
No, I've not.
Okay, it's like $200 keycaps you can get for your keyboard.
Thing.
Yeah. But they sound so nice. But they're MX only. You can't put them on like chalk switches.
Oh, okay. Well, that's why I got the sliders, so I got a really good retro keycap set from I forget where from, but definitely the nicest keycaps that I've had. So
yeah, these like the ceramic ones, they make like a really gentle like sort of like talk sound.
Oh, I miss that. The Topre, that is what I miss, is the talk sound. One of my dreams is to start a keyboard and coffee shop.
What? Like
but it would be
selling keyboards?
Niche. Yeah, well, it'd be a coffee shop.
Yeah.
That is just like all geeked out, and you can also like test out and buy keyboards.
Yeah. I mean,
it's not feasible, but I would like to be there all day.
If I had to hazard a guess, like the people who are enthusiastic about keyboards and people who are enthusiastic about coffee, there's some overlap there for sure.
Yeah.
Yeah. That's fun. That's super fun. I was just thinking about the phrase big keyboard, and then like how getting a 30% keyboard might be like something from big keyboard, but it's also small keyboard because anyway, just getting lost in that one.
Oh, good tangents.
Yes. All right. I feel like we've come to we've made some decent progress today. We solved at least 2 bugs, I want to say.
Okay.
And then little refactor dance on our code. Now we have the nice little high level interface that we can now begin to like factor out, hopefully.
And the more important thing is we've got linkage for the next episode. So
yes.
All right. Well, that's probably a good place to stop. So yeah. Until next time, I suppose.
Till next time.
All right. Thank you as always. Catch you in the next one.
For sure.